Hello world, it's Craig. This is another follow-up on these reproduction solid-state music CB1A S-100 8080 based single board computers. I wanted to finish up the video on this project before I moved on to something else. So here's the original solid-state music CB1A. And in the last video, I showed you this version, and it was one that had a dual socket up here in the corner. You could either put in a 7400 to make an RS latch, or you could take that out and you could just use the other half of this socket and use a parallel ASCII keyboard. And I mentioned, when I told you about this one, I mentioned that I made another version of this that just had a little bit different layout. It still was based on the RS latch. This is that version. And the difference is that instead of having the extra socket up here in the corner, it has two sockets, and the 8212 and the 7400 for the RS latch kind of cohabitate. They're exclusive, and you can either put in one or the other if you're going to use the keyboard port or if you're going to use the serial port. And then the first 6 pins up here in this socket match the standard USB to TTL level serial adapters. So all you have to do is plug the serial adapter into those first 6 pins. So far, these all seem to be functionally equivalent. I've done more software on it, and unless you want to use the serial port, this functions the same as the original. Now, in that first video, I mentioned that I also had another design that was a little bit further from the original intent of solid-state music, and this board is going to be the topic of this video. As I showed you in an earlier video how solid-state music did a fantastic job of not having any leftover logic gates. However, as I really got to looking into these boards and I started doing the layout, I realized that there were a couple of artifacts left over from the original CB1 version of the board. This is the CB1A schematic, and if we look at the RAM selection dip switch in the CB1A user's manual, I thought these down here underneath the exclusive ORs were just these missing connections. I thought they were either a printing or a scanning error. But then I realized that since the CB1 version only had 256 bytes of RAM, and they wanted it to be completely assignable to any quarter K boundary, they needed these 2 extra switches. And when they went up to 1K on the CB1A, they only needed to make it selectable for any even 1K boundary. And so those 2 switches are left over. They're unused, as well as these 2 exclusive ORs, and then a couple of pull-up resistors. So it wasn't much, but it was a start. There were now 2 open collector exclusive ORs, a handful of 2.7K pull-up resistors. But even if I could do the decoding for an output port, there isn't a spare latch, which is what I would need to make an output bit. But I might have been able to cobble together a couple of spare NANDs so I could make another RS latch like I did in the other board. But I wanted to go a little bit further than that, even if it was venturing a little further away than the original intent of this board. When I started looking at this board, you can see there's no unused gates, but there are several underutilized gates. Here in U19 is a 2-input NAND, but it's just being used as an inverter. And since I had those exclusive ORs, I could use one of those as the inverter, and that would then free up this 2-input NAND to operate as a 2-input NAND. And also over here, we can see in U18, 9, 10, 11, there's a 3-input NAND that they're just using as a 2-input. So I could take that 2-input NAND over here, and that would free me up a 3-input NAND. Play this game over and over again, and here just to the left of that's another U18 gate. They're doing the same thing. U6 is just acting as another inverter, the same for U19. And U24 here on page 2 is a dual 4-input NAND, but they're using part of it as a 3-input NAND, and here they're only using it as a 2-input NAND. So you can see that with a little tweaking of the utilization and maybe moving things around a bit, that there's actually a number of leftover gates on this board. So my goal was to create a full output port that was separate from the existing input port. And I wanted that to be a full 8-bit port. To do that, if we look at this logic, the first thing I needed to do was have a signal that indicates when any port is being addressed on this board. So I need to separate out the port address when I'm in a port I/O cycle, and then glue that together with the port input or the port output signals to get the direction. And then finally, look at the least significant bit of the port address to see if the input was either the keyboard data or the strobe, or the 8212 status bit. So they had this all convoluted down here. They were bringing this input signal in much sooner than what I needed it to give me just the port address signal, I needed to get this input port signal out of this NAND. They're only using 6 of the 8 inputs, and I needed one of them off anyway, this gate. So I swapped out this 8 input 7430 NAND U16 with a 7421 dual 4 input AND. That did a couple of things. One is it broke up these signals, and it also gave me a more favorable logic level that I needed this early in the signals. So this new signal goes high whenever an onboard port is selected, either read or write, and the base port is still set by that dip switch. So it's either the address that's set by the dip switch or that address +1, because the least significant address bit isn't being decoded yet. And I was short a NAND, but it was a no-brainer to swap out U24, which was a 7420 4-input NAND, and I put in a 7410 triple 3-input NAND. So I didn't lose anything there, and it gave me an extra 3-input NAND. So now I have this port select signal. It's positive logic. Using that and the input port strobe gave an active low port read signal out U24A and an active high port write signal out of U16B. So now I had the read signal that I needed to do the existing port and almost have the write signal that I need for the new port. I needed to use one of those extra exclusive ORs as an inverter here on the right, but I was able to get an active low port write strobe, and that's the strobe that I then use to clock the output latch. Cosmetically, it looks just the same as the original board. 2 of the chips were different and some of the signals were routed, but the design was pretty faithful to the original. Now, I thought about playing more games with hiding this port somewhere on the board underneath something else, but this is a big open area over the top of this 8080 that it was just asking to be used. So that's what I did. Here in this space, we have a 374 octal latch and a 14-pin dip header, just like the original keyboard header. You know, for all practical purposes, this looks like what the board should have been when Solid State Music originally made it. They have an 8-bit input port and an 8-bit output port. Now this octal latch gives us complete byte of latched output to complement that byte of the input in the original. And I peeled off 1 bit off of each of these ports for this TTL level serial port up here at the top. So as before, this board takes 2 port addresses, which with the base 4 bits being set by this, well, the least significant bit is used to tell you if you're doing the even port or the odd port. The next 4 addresses are set by this switch, and then the upper addresses are all fixed to 0. And that's just the way that it was in the original board. When reading the port, if you read it, the port which ends in 0 with a status port, you get the status of the 8212. And if you read the port that ends in a 1, then you're getting actually the data from the parallel input. Now, since one of these switches was unused, the 2 address switches that they had that they didn't need anymore, I took one of those switches and I used it to hold the input strobe to this 8212 high when that switch is closed. That puts the input latches in the 8212 in transparent mode. So the 8212, it has a set of input latches and then it has a set of bus drivers. Taking that strobe high makes it so those input latches are transparent so that then whenever you enable the bus drivers, the input is transparent and whatever's on the input will come right out to the output. So that means that the data doesn't need to be strobed in with the keyboard. It's always available. And basically then operates as a regular input port rather than a strobed and latched input port. Now the data is written to this irrespective of the least significant bit of the address. So it latches the data out, or if you're writing, either the port that ends in 0 or the port that ends in 1. And then all 8 bits as well as ground and power are available on this little 14-pin dip. So far, I'm pretty happy with this board. It worked pretty good right out of the gate. I have found 1 change, maybe 2 changes that I want to make. They're both very minor. One is that I'm going to put that strobe tie up rather than have a hard tie to the +5. I'm going to put that through a pull-up resistor so I don't get any contention in case you happen to have a keyboard in this. It'll at least be a little bit protected. The second is I have a little LED that I put up here at the top. That LED right now, I have one of the exclusive ORs inverting it and driving it, and using it as the transmit bit. But once everything's up and running, that's kind of wasted as the transmit bit. It sits there and it flickers, so you can see that you're transmitting out to the serial port. But really, I think that's probably better off as just a general output display if you want to make a heartbeat display or something like that. So I'm going to move that off of the serial port. Functionally, except for the LED, I don't think the next version will act any different than this version. Now, I may start the build files and documentation with this version, or it depends on what else I have going on. I may wait until the next version before I put the build files and the documentation up on the project site. It depends on kind of, well, obviously on the level of interest. And as usual, I do have a couple extra of these boards. I've given a few of them away already, but I do have some extras of this board, just bare boards. And usual provisos, give you a bare board if you want one, and just ask that you want it bad enough that you'll pay the shipping for it, and that you will build the board and get back to me if you find any problems with it. If you do want one of these boards, and I think I still have I may still have some of these other boards left. So if you don't like this design, you want the original RS latch design, let me know. But I still have some boards left. Leave a comment below to save your place in the queue, and then email me with the details, and you can either PayPal me for the shipping or send me a label. Okay, so that's it for this video. I just wanted to finish this up before I moved on to the next project. Thanks for watching. I will talk with you later. Bye-bye.